Hey guys, in this video let us understand how to write SQL queries using window function. Window functions are also referred to as analytic function in some of the RDBMS. If you're planning to attend an SQL interview, then you can almost be certain that there will at least be one question related to window function. So it's not just about clearing interview, but by knowing how to write SQL queries using window functions, you should be able to solve some of the most complex SQL queries pretty easily. For example, let's say you have been asked to write a query where you want to fetch the top 3 employees from each department in your employee table who earn the max salary. Or let's say you have been asked to write a query where you want to display the minimum and the maximum salary in each department corresponding to each employee record. Then this kind of queries would almost be impossible to write without using a window function. The syntax to writing SQL queries using window function is slightly different from writing any other SQL queries. So I'm going to explain you the exact syntax and also the different types of analytic or window functions that you can use in SQL. In this video, the window function that I'm going to cover are rank, dense rank, row number, lead, lag, and I'm also going to show you how you can use aggregate functions as analytic function in SQL. Before we can start writing queries, if you find this video useful, then please make sure to like, it helps me a lot. Also, I regularly post videos related to learning SQL, Python, database concepts, as well as data science related concepts. So if you're interested in these kind of concepts, then please make sure to subscribe to the channel. Thank you, and let's begin. The best way to understand window function is by first going through an aggregate function. To do that, I have already created an employee table, as you can see here. So it has 4 columns: employee ID, employee name, department name, and salary. Under department name, I have 4 different departments. So I have admin, HR, IT, and finance. Under each of these departments, there are a few employees. Totally, there are 24 records. And the salary details of each of these employees is mentioned in this column. Now, let's say if I wanted to find the max salary earned by an employee in this table, then I can just write the query like select max of salary as max salary from employee. Now if I execute this, you can see that I'm able to extract the max salary here. But let's say if I wanted to extract the max salary earned by an employee in each department, then I can do that by using a group by clause. So let's say I just add a group by department name, and let me just show it here as well. Now if I execute this query, you can see that I'm able to extract the max salary corresponding to each department in the employee table. This is fine, but let's say if your requirement is to extract the max salary in each department, but along with that you also want to display all the other details of the employee tables, then we would not be able to do that just by using aggregate function or group by clause. Maybe we can use a with clause or write some other subqueries to do that, but the best way to form this kind of query would be using a window function or an analytic function. Now let me write a query how we can do that. So I'll just say select star from employee. I'm going to give an alias like e, so I just say e dot star, and now I'm going to use max, but this time I'm going to ask SQL to consider max as an analytic function or a window function. How I can do that is by using a clause called as over. I'm going to give an alias here saying like max of salary. Now if I execute this query, you can see that I'm able to extract all the records in this table. So even all the columns from this table are fetched. Along with that, I have an additional column here that is the max salary. What this column is having is for every record, it's having the same value, that is the max salary that it was able to find from the salary column in this table. Now let's look at this syntax in detail. So basically I'm using a max of salary, which basically is an aggregate function, but also I'm using an over clause. So since I'm using an over clause, what SQL will do is it will not treat max as an aggregate function. It is going to basically treat it like a window function. Over is basically used to specify SQL that you need to create a window of records. So if I don't specify any column like I have done here, I have not specified any columns inside this. What happens is SQL will create one window for all the records in this result set. So basically there are 24 records, it's going to create one window, and for that one window it's going to apply this particular function. So in all of these 24 records, it's going to look for the max salary, which in this case is 11,000, and that value is going to be shown corresponding to each record in this result set. Okay, now let's say if I wanted to extract the max salary corresponding to each department, then what I can do is I can use a clause called as partition by. So let's say I just mentioned partition by, and then I mentioned the column name. So in this case, let's say department name. What it's going to do is for every distinct value that is present in this column, it's going to create one window. Okay, and then it's going to apply this function to each of those windows. Okay, now if I execute this query, the max salary that you can see here is different for each of the department. For example, for admin, the max salary that is being shown here is 5,000, because the maximum salary that is earned by an employee who belongs to the admin department is only 5,000, hence 5,000 is displayed here. But when it comes to finance, the maximum salary earned by an employee who belongs to the finance department is 6,500, hence 6,500 is displayed for every record in the finance department record. Okay, now the same thing happens for HR, and the same thing happens for the IT department as well. So this is basically the syntax of how you can use a window function. In this case, I'm just using an aggregate function that is max. I can also use min, sum, average, count, or any of the aggregate functions. I hope this was clear. Now let's look at some of the functions which are specifically used as window functions in SQL, and these are common across most of the RDBMS like MySQL, Microsoft SQL Server, Oracle, PostgreSQL, or any other popular RDBMS. Let's start by looking at row number. As the name suggests, it's just going to assign a unique value to each of the record in the table. I can write the query like select e.star from employee. I'll give the alias as e, and I'm going to use the row number. So I say row number over. I'll not pass any column for now, and I'll say rn, okay, as the alias. Now if I execute this query, you can see that for every record in this table, I'm able to get one unique identifier. Now, in this query, I have not passed any column inside the over clause, and this is why SQL will treat all of the records in this table as one window, and for that whole window, it's going to assign a row number. Okay, so there are 24 records, so 24 numbers have been assigned. Now, let's say if I wanted to assign a number based on different departments, then what I can do is I can just say same like the previous query, so partition by department name. Okay, and now if I execute this query, you can see that I have the department admin. It has 4 records, and for this records, the row number is assigned as 1, 2, 3, 4, and after that, for the records belonging to the finance department, the row number gets reset, so it again starts from 1 and then goes up to 4, and then for the next department HR, again the row number will reset from 1 and again go up to the number of records that is present in the HR department. Okay, and the same thing happens for IT department as well. So as you can see, what's happening is, because I used over and I mentioned the department name as the column inside my partition by clause, for each unique record that is present in the department name column, it's going to create one window, and inside that each of this window, a row number function will be executed. So for each window, based on the number of records, one unique value will be assigned. Okay, I hope this was clear. Now, you may ask, what is the actual use of having this kind of functions? Where can it be useful? To showcase that, let's say if I had a requirement where I wanted to fetch the first 2 employees that joined the company in each department. Let me make an assumption that the employee ID of employees who joined previously would be lower than the employee ID of the employees who joined later on. Okay, so to do that, I'm just going to copy this whole thing here, and I'll paste it here. So if I execute this query again, you can see that I'm able to get the row number that is assigned for records belonging to each department. But then if you look carefully, the employee IDs are basically not sorted, right? So if you just see the records in the finance department, you can see that the first employee ID is 118, then 116, 106, and then 104. So this is not very sorted. So it looks like the first employee to join was Darwin, that is 104, and then 106, and so on. Okay, now to sort this data in the proper order, we are going to use the order by clause. So after this partition by the department name, I can just mention the order by here, saying that order by, let's say I want to order it by based on the employee ID. Okay, now if I execute this query, you can see that now if I go back to finance, the data is now sorted as per the employee ID. What my requirement is that I want to fetch the first two employees from each department. Okay, so I know that I want to fetch these two employees, that is 101 and 108, and then I want to that is from admin, and then from finance I want to fetch these two employees, and then I want to fetch the first two employees from the HR department, and so on for the IT department as well. Now how I can do that is I can just use a subquery. Okay, so I just say select star from this one, and I'll just move it ahead, and I'm going to give an alias to this, like let's say x, and I say where x dot rn is less than 3. Okay, now if I explain you this query, what I'm basically doing is this inner query that I'm having here, if I execute, it's basically fetching all the records from the table, and for based on different group names that is mentioned here, it's going to assign a specific row number. Okay, now I'm only interested in the records where the row number is 1 and 2. Okay, because these are my first two employees in each department. So I'm passing this whole thing as a subquery, and I'm giving an alias to it as x, and I know that the row number 1 and 2 is what is the records that I want to fetch. So I just say x dot row number less than 3. Now when I execute this query, you will see that I'm only able to extract 8 records because it's 2 records from each department, and I have 4 departments here. So the first 2 employees from the admin department are extracted here, the first 2 employees from the finance department are extracted here, and so on for all other departments. So this is one use case of where you can use row number to extract a specific record from your table. Okay, I hope this was clear. Now going ahead, let's look at another window function, that is rank. So let's say you have a requirement where you want to fetch the top 3 employees who earn the max salary in each of the department. So basically what you need to do is you need to rank the employees based on their salaries, and then you need to fetch the top 3 employees from each of the department. Okay, so to achieve these kind of results, the best way to write a query is using the rank window function, okay, or the dense rank based on what you need. But let's first look at rank. So let me write a query for that. So let's say select e dot star from employee alias e, and I'm going to use an rank function here. So let's say rank. Okay, I don't need to specify a column name here, and I just say over, and I'm going to, because I need to rank employees based on their department, I'm just going to partition them by the department name. So I just say partition by department name, and now I'm going to order by their salary. So I want to find employees who are earning the max salary, right? So I say order by salary, but I need to make this order in the descending order. So I say DESC. So this will order by salary, but in the descending order. Okay, and I'm going to give an alias saying like RNK. Now when I execute this query, you can see that I'm able to extract all the records, and there is a rank that has been given to each of the record corresponding to each department. Okay, so let's first look at the admin department. Under admin department you have 4 records. So you have the employee with the highest salary is 5,000, that is at the top, and it has got the rank as 1. Next there are 2 employees who earn the same salary, that is 4,000, and both these records have been given the same rank, that is 2,000. Okay, and then the next record is the next employee who is earning 2,000 is actually given the rank as 4. This is because whenever we are using rank, if it finds a duplicate value, it's going to assign the same rank to both of these records. But for every duplicate record, it's going to skip a value. So it finds a duplicate record here, so it gives the same rank, but for the very next record, it's going to skip a value, okay, when it's assigning the next rank. This is what rank does. Now let's say if I wanted to find the employees with the top 3 salaries, okay, what I can do that is, again I'm going to place this inside a subquery. So I just say select star from, okay, and here I'll just move it ahead, and I'm going to give an alias to this subquery as x. I say where x dot rnk is less than 4. Okay, so if I execute this query, now as you can see, only 14 records have been extracted here, and it's only extracting those records where the rank is less than 4. So basically we were interested in only employees who had the salary rank as 1, 2 or 3. So you can see in admin I only had 1 and 2 because I think there are 4 records. Now if I just check back here, you can see that under admin I only had the rank as 1, 2 and 4. So there was basically no rank as 3 because these two had the same rank and the next rank got skipped. So when I look at the whole data here, this query is going to extract me all the records of employees who are earning the max 3 salaries in each department. Okay, so I hope this was clear. Now this is how we can use the rank function to achieve this kind of requirement. Now there is another function that is called as dense rank, which is almost very similar to rank, and there's just one difference. So I'm going to talk about that right now. So for that, let me just copy this query. Okay, so what I'm going to do is I'm going to use the same query, but I'm just going to copy the same thing and paste it and just make it dense rank. Okay, so I just say dense rank, and now if I just execute this query, you can see that now there's another column added here which is dense rank. And if you see the output here, what it's doing is for every salary, basically for every record in your department, in this case, so let's say admin department, I have 4 records. The first record is the one with the highest salary, so the rank is 1 and the dense rank is also 1. This next 2 employees are having the same salary, so the rank is 2 and the dense rank is also 2. But then the next employee who is having the salary as 2000 is having a rank as 4 because one value got skipped because the previous record had duplicate rank. But in dense rank, as the name suggests, it will not skip any value. So this is the only difference between using a dense rank and a rank. A rank will skip a value for every duplicate value that it found previously, whereas a dense rank will not skip a value. Okay, so I hope this was clear. Next, let me just add another column here. So just to explain you how different row number is. Now you might also ask why we are not passing any column inside any of these functions, because rank, dense rank and row number are just functions which will assign a value for every record which has been detected or identified by what you have mentioned inside your over clause. So now you can see the difference here. The record with 5000 is all having a rank as 1, dense rank 1 and row number as 1. But then the next 2 records which have the same salary, the rank and dense rank are having values as 2, whereas a row number does not care if there are duplicate records or not. It's just going to add a unique number to every record. So this is basically the difference between row number, rank and dense rank. Okay. Finally, let's look at the last 2 window functions that we are going to cover in this video, which is lead and lag. So let's say you have a requirement where you want to check if the salary of the current employee is higher or lower than the previous employee. Then we can use the lag function to do that. So let me write a query for that. So let's say select e.star from employee, and I'm going to use the lag window function here. So I mention salary as the column that we need to check, and then I mention over and I do a partition by the department name and order by employee ID. I want to check for the previous employee, right? So the data needs to be in the order of the employee ID. So I say as, and I am going to pass previous employee salary. Okay, something like this. Now if I execute this program or this query, you can see that what's happening is in this new column, the previous employee salary, it's actually going to fetch the salary of the previous record. So in this case, I have grouped the data or partitioned the data based on the department name, and then I have sorted it based on the employee ID. Now in the first record, the employee ID is 101 and the salary is 4000, but there is no record previous to this. So by default, the lag function will return as null because there was no previous record. When we come to the second record, it's going to look for the previous record in this case. So the previous record, the salary was 4000. So in this record, the previous employee salary will be displayed as 4000. Now when we come to the third record, you can see that the salary of the previous record was 4,000, hence that is what is being displayed here. And when we come to the fourth record, the same thing continues. Basically, the value of salary that was present in the previous record will get returned here. Okay, so basically, as the lag name suggests, it's basically the record from your previous rows. Now, there are a couple of arguments that we can pass here. For example, let's say if I pass 2 and then if I pass here as 0, what this will do is, by default it will always look for the previous record, that is one row prior to the current row. Okay, but I can mention how many rows prior you want to check. So if I mention 2, what it's going to do is it's going to look for 2 records previous to the current record. Okay, and then the last argument here is basically a default value. So in this case, since there was no previous record, it returned null by default, but here I can specify a particular value what needs to be displayed here. Okay, so if I execute this program now, you can see that it's basically checking for 2 records previous to this. So 2 records previous to the first record, basically there is nothing, so it's going to return the default value, that is 0. The same thing happens on the second record. When we come to the third record, it's going to look for 2 records previous to the current record, that is this one. So it's 4,000, so that is what is getting displayed here, and so on and so forth. Okay, so this is basically what a lag does. Now, almost similar to this is lead, and as you can already imagine, lead is basically the rows that are following the current record. Okay, so I'll just remove all of this, and I'll also remove this now, and I'll say this is not previous, but it is the next employee salary. Okay, so if I execute this, now you can see that in the first record, it's going to look for the value of salary in the next record, that it is 4,000. So that is what is getting displayed here. Now, when we come to the second record, it's going to look for the salary in the next record here. This salary, so that is 2,000, and that 2,000 is what is getting displayed here. And when we come to the third record, it's going to look for the salary in the fourth record, that is 5,000, and that 5,000 is actually being displayed here. Okay, so this basically what lead and lag window function can be used. There are a few use cases where this kind of queries can really be helpful. For example, let's try to execute a query which will return this kind of result, where we want to fetch if the salary of the current employee is higher than the previous employee, then we display something like higher, or we display something like lower. Okay, so to do that, let me just copy this query here, and I'll remove this. I don't need this. And what I'm going to do is I say case when salary, right, e dot salary is greater than this whole thing. Okay, so greater than the previous salary. So I just paste it here, and I say then if it is greater, then I say higher than previous employee. Okay, and now let me just copy this whole thing, and I just paste it here, and I'll paste it here again, and I say end, and I'll call this as salary range. Okay, now if this is greater, I display higher, but let's say if it is lower, then I say display as lower, and if it is equal to, then I say same as the previous employee. Now if I execute this program, you can see that, okay, so you can see that the previous salary here is null, so basically it returns me as null. Maybe we can add another condition where it is null. For now, let's ignore that. And since the current salary and the previous salary are same, I'm just printing it as previous, the salary is same. If here the salary of the current employee and is lower than the salary of the previous employee, hence it is printing lower. Whereas in the record number 4, the salary of the current employee, that is 120, employee ID 120, is higher than the salary of the previous employee, that is employee number 113. So it's displaying higher than previous employee. So this is just a simple use case where we can use lead and lag to do certain analysis. I hope all of this was clear. There are a few other window functions as well, such as nth value, first value, last value, end tile, etc. So if you would like me to make another video covering all the other window functions, then please leave a comment below. I'll try to do that. If you like this video or if you found it useful, then please make sure to like and also subscribe to the channel for more such learning SQL and learning Python or data science related videos. Thank you and see you soon in the next one.